Good day, dear ladies and gentlemen. Everybody, especially boys, in the childhood like to play different kind of machines, and some of them even dream to construct something new of them. But our guest, I think, has never expected since childhood to construct not simple machines, but molecular machines. So, a very warm welcome to Jean-Pierre Sauvage, 2016 Nobel laureate in chemistry. Jean-Pierre, it's a great pleasure. It's great to have you on a discussion. Thank you so much.
Thank you.
Okay. And the first thing I would like to learn is the way in the scientific activities to being a Nobel laureate. So your colleague Bernard Feringa in 1999 has created first rotary molecular engines.
A
How?
rotary motor, yes.
Yeah. Oh, sorry. And how long did it take for each group of scientists, including your other colleague Fraser Stoddart, eventually to become Nobel laureate?
Yeah, it's a very good question, But you have to realize that you do not say to yourself one day, I want to win a Nobel Prize, and I will do this and this and this to be very successful and finally to be awarded a Nobel Prize. You cannot reason this way, You do your research, you are excited by some topic, you do some work in a given topic. At some stage, you may want to do something else. You jump from a given field to another field. And after maybe a couple of years, you reorient your research. So it's not a linear approach. You are not on a straight road, looking at the end, looking at the infinite. It's much more chaotic, for all the people I know. So at some stage, you decide that you will try and make molecular machines. But you have already a big background, You have a scientific past behind you, which helped you make molecular machines. Okay. So you have to calculate overall. I mean, it took a lot of years, a lot of time, many years. But these many years were not completely devoted to molecular machines and molecular motors. They were devoted to many, many other topics, many other research areas.
All right. So, and personally, how do you think, what is the most interesting and the most significant work do you have? I mean, as you said, you have a very wide range of studies. So what is the most you think significant and important?
Yeah. The most significant. So we have been, maybe I can explain you,
right.
What I have been doing and what we have been doing, my co-workers and me. We have been working in several fields. One, which was very important, was water splitting, trying to split the water molecule to H2 and O2 using light energy, and in particular using solar energy. It's a very important project. Many people have been working on this project for many years. Of course, it's a beautiful reaction if you can succeed, because it would afford dihydrogen from water and from solar light. So that would be fantastic, because dihydrogen, as I'm sure you know, is the ideal fuel. When you burn dihydrogen, you generate water, and that's all. And so that was a big, big project. And from this project, more or less by accident, we made catenanes. Catenanes are interlocking rings. I'll just show you the simplest catenane. Yeah. It's a two catenane consisting of two rings, interlocking rings.
Okay.
And having done that, we realized that we could try to set the molecules in motion. And so from catenanes, we moved on towards molecular machines and molecular motors. And we started to make a rotary motor, a catenane for which one ring will glide within the other ring. We partly succeeded, but we had no control over directionality. It was kind of a pirouetting machine. The ring was going one direction or the opposite direction, not really rotating, but we said pirouetting, oscillating. And that was in 94. And after that, I think it was exactly at the same time as the very first paper published by the group of Fraser-Stoddart. It was the beginning of the molecular machine field. And as you said, in 1999, Ben Feringa published a fantastic piece of work with his group on a rotary motor. And then it developed, it grew up. And we have been interested in many various molecular machines since the 1994 initial work.
Okay, that's amazing. Yeah, thanks. The application of your discovery in molecular medicine, in particular targeted drug delivery using molecular machines. Do you think the development of such technologies and methods can save us from surgery, from radio or chemotherapies in the fight against cancer? If talking about
that's a very good point. Yeah, it's a very good point. I think you speak about probably the most exciting potential application of molecular machines, which will be to make biocompatible molecular machines, which is not the case today. The molecular machines, the many molecular machines which have been made by chemists, not only by Stoddart, Feringa, and my group, but by nowadays many groups, are not biocompatible. They would be toxic. They would not be accepted by a living organism. And so I think it's a big project for the future to mix, biocompatibility and molecular machines and motors, and then to see their effect, when you inject them in a body, to see whether they can, in fact, as you say, navigate, find targets to be destroyed, like malignant cells, cancer cells, or viruses or bacteria. It's probably one of the big projects. But I'm afraid it will take time. We are still relatively far away from using those molecular machines in medicine.
Okay. We'll hope that it will be as soon as possible in any case in the future. And the point that pharma industry should be interested in that as well. Okay, you believe in genetics. Okay, and there are ancient books which could possess some probably dubious kind of information, but in any case, there is information that people previously lived up to 1,000 years, and more precisely, the example of the person who is called Methuselah, who probably lived like 969 years of life. Do you think our genes have degraded from that time, possibly, to the life expectancy of the indicators that we have now? How do you think?
I do not believe that anyone on Earth has lived for more than a century.
Okay.
Yeah, I'm not a believer.
But you believe into the genetics. How do you think could it be possible to extend the life expectancy in future as well? Not like
Honestly,
even for centuries, but at least probably like 200 years, maybe.
I don't know. I mean, my knowledge of genetics is not good enough for me to have an opinion. I'm not sure it would be desirable.
All right.
You know, maybe you will find it shocking, but I don't think it would be a good thing, you know, if we could increase the lifespan of human beings up to 2 centuries, 200 years. The planet is limited. You know, the number of people cannot increase and increase and increase infinitely. And I think it's good to have, you know, new blood, fresh blood, you know, and young people and older people to disappear. This is what I believe.
Yeah, it will be a matter of a quality of life in this case, but
yeah.
Of course. But not about the genetics. Is there an area of expertise in which you would like to be more competent for now?
In biology, molecular biology, you know, it's really fascinating. And look at the last chemistry Nobel Prize, you know, CRISPR, you know, molecular scissors to cut pieces of DNA and paste pieces of DNA. You know, the work of Charpentier and Doudna. I believe this is fantastic. And I would like to be perhaps more educated in molecular biology. But you cannot learn everything. So.
Of course, but it's interesting. Okay. And science occupies a big part of your life. But what else is important for you?
For me, family life is important. I have always been very cautious, you know, to have a rich family life with my wife, with our son, with our grandsons now. And in terms of culture, I love music. So I'm a music consumer, various types of music, you know, from blues and rock to classical music, Baroque music, but even modern classical music.
That's great.
Mostly.
I understand. Okay, thank you for sharing this. It's interesting very much. All right. There is such information that you gave lectures and participated in various events of Russian universities. And what is your experience of communicating with the Russian colleagues, taking into account that you are also a foreign member of the Russian Academy of Science?
Yeah, well, I have a couple of very good friends in Russia, especially in Moscow. We had a privileged relationship with some people and even some students coming over from Moscow and spending some time in our group. So I get along very well with the Russians, very well. There is a university which I have a special connection to, which is the Friendship University, World Friendship University.
Yeah, People's Friendship University. Yeah.
People's Friendship University.
Okay.
And yeah.
All right, great.
Which I should visit. You know, I didn't visit it this year because of the coronavirus.
Yeah.
Very unfortunately, but I will visit it as soon as I can.
All right. Okay. I also want to ask you about the system of scientific publications. How comfortable is it for you at the moment, taking also into account that you have lots of publications, and high citation ratings?
Yeah, you mean the policy, generally speaking, the policy for
The publication process, some probably, ethical measures in this process. How is it comfortable?
Things have changed. Things have changed dramatically since the beginning of my career.
Okay.
Because when I was young, let's say when I was a PhD student, at the beginning of the 70s, you could read the literature. You could read the chemical literature because there were not 2 million pages published every day. You could read the 30 journals, and so this is, I think today it's a big problem because the people cannot read anymore. It's my case also. You cannot read the literature anymore. You can read just bits and pieces, of the literature.
Yeah, it's even time consuming to filtrate this kind of information.
Yeah. No, it's a big problem. And in terms of ethics, we didn't count our publications in the same way as today. A good group of people was publishing 10 papers a year or so, and everybody was happy. And nowadays, if you are a group of 15 people, you have to publish at least twice or 3 times as much. And so it forces you to publish and publish and publish, knowing that very few people will read in detail what you are publishing. And this is a big problem. You do not really believe in what you publish.
Yeah, I really understand you and agree with you.
Yeah.
Okay. And I'm very curious about young scientists and their scientific career. How do you think, how great is the influence of scientific leader and mentor for some person in order to be as much as possible successful in the scientific career? Or you think probably it depends personally for the individual himself?
Yeah. Well, first I should say that it depends very much on the country also. Mm-hmm. In some countries, the young people are pushed, they are really helped. And maybe you will be surprised, but I think this is the case in China. China is a country I know quite well. I used to visit, universities frequently. Mm-hmm. And you see many young people who are incredibly enthusiastic, and motivated. And they are very much supported by the system, by the Chinese system. The selection mode is very strict. It is very difficult to be successful. But once you have been identified as a promising young scientist, you will be helped. In other countries, it is different. It is the same, more or less, in certain countries. In Europe, it is the same in the US. But in some other countries, young people are not so well treated. And this is something I deeply regret. Young people should be pushed, because they are the future, and they should be given all the facilities they need to do their research, well, especially the good ones. And the mentor, of course, has an influence, because young people, they need some models. They have to think of some people, try to identify them to these models. And so it's important, of course, to have some heroes, some heroes you would like to be similar to. That's important.
All right. Yeah, I agree with you. Thanks. And also, Jean-Pierre, we have one secret together with you, but I'm sorry, I need to disclose it. The fact is that we rescheduled this talk with you for today. Now it's Wednesday, 21st of October, and it's your birthday.
Yes, you're
So,
right.
so happy birthday to you. And on behalf of all team and our scientific community, I wish you bliss, prosperity, calmness, hope, love, and as well as great success in every single effort. And also, and also in this regard, I want to ask you, what would you like to wish to yourself for the next year of your life?
Well, I would like to wish to myself to still be in good shape and to still be intellectually reasonably good. I would like to be intellectually fast and be able to understand rapidly what I read, what I'm discussing with the others. This is very important.
All right.
Alex, thank you for your good wishes, and thank you for wishing me a happy birthday.
Yeah. Thank you so much. It's a great event and great opportunity. I actually feel myself like I have been invited to your birthday, just like we talked today. So thank you so much, Jean-Pierre Sauvage, and it's great. And thank you so much again. Wishing you all the
Thank
best.
you.
Yeah.
Thank you.
And have a great day today.
Yeah. You too. Thank you, Alex.
Thank you so much. Bye-bye. Bye.
Bye.